أعزائي الطلبة، السلام عليكم ورحمة الله وبركاته. أهلا بكم في درس جديد من دروس الألجبرا. درسنا النهاردة هو complex number. The complex number is the number which can be written in the form of a plus bi, where a and b are real numbers. a and b are real numbers. So complex number a plus bi, we have a is the real part and the bi is the imaginary part. Example: solve the equation 9x squared plus 125 equals 61. Solution: the equation here is 9x squared plus 125 equals 61, so the required to find the value of x or the values. So by adding negative 125 to both sides, we have 9x squared plus 125 minus 125 equals 61 minus 125. We wanted to get rid of positive 125, so we must add negative 125 to both sides. So 9x squared equals negative 64. How we get it? 125 minus 125 equals 0. So the left hand side will be 9x squared only, and 61 minus 125 equals negative 64. 61 minus, you can use your calculator, 61 minus 125 equals negative 64. So x squared equals negative 64 divided 9. Or you can say dividing both sides by 9. Dividing both sides, the left hand side and the right hand side, by 9. So we get x squared equals negative 64 over 9. And x equals positive or negative square root of negative 64 over 9. We take the square root to the both sides, so x squared will be x, and the negative 64 over 9 will be root negative 64 over 9. And don't forget, we have two solutions. One of them is positive and the other is negative, and we can write x equals positive or negative square root of 64 over 9 I as negative root negative 1 equals I. Root negative 1 equals I. So once more, root negative 64 over 9 equals root 64 over 9 I. And to complete the solution, positive or negative, we write it. Square root of 64 is 8, square root of 9 is 3, and don't forget to put I. So we have two values of x. X equals positive 8 over 3i, and the other value is negative 8 over 3i. And this is the solution. Question: solve each of the following equations. 3x squared plus 27 equals 0. 5x squared plus 245 equals 0. 4x squared plus 100 equals 75. We want to find the solution for these three equations in the set of complex numbers. So starting with A, we have 3x squared equals negative 27. Here 3x squared plus 27 equals 0. So 3x squared equals negative 27, and x squared equals negative 27 over 3. That means x equals positive or negative square root of negative 27 over 3. Negative 27 over 3 equals negative 9, and you know that square root of negative 1 is I. We write it, and the square root of 9 is 3. So the final solution to x equals positive or negative 3i. Again, x equals positive or negative 3i. B, 5x squared plus 245 equals 0. Then 5x squared equals negative 245. Dividing both sides by 5, we get x squared equals negative 245 over 5. Dividing both sides by 5, we get x squared equals negative 245 over 5, and x equals positive or negative square root of negative 245 over 5. Negative 245 over 5 equals negative 49. So we can say that x equals positive or negative 7i, as square root of negative 1 is I, and the square root of 49 is 7. C, 4x squared plus 100 equals 75. Again, 4x squared plus 100 equals 75. So 4x squared equals 75 minus 100. We take it from left hand side to right hand side, and we change the sign. From positive it will be negative. So we can write 4x squared equals 75 minus 100. And the 75 minus 100 equals negative 25. Then x squared equals negative 25 over 4. And then x equals positive or negative. We have two solutions for this equation. Square root of negative 25 over 4, which equal positive or negative 5 over 2i. Positive or negative 5 over 2i, as square root of 25 over 4 is 5 over 2, and the square root of negative 1 is I. Equality of two complex numbers. If A plus BI equals C plus DI, then A equals C and B equal D. A equals C and B equal D, and vice versa. So the real part in the first complex number equals the real part in the second complex number, and the imagined part B equal D. Example: find the value of x and y which satisfies the equation 2x minus y plus x minus 2yi equals 5 plus I. In this equation, we have two sides, the left hand side and the right hand side. In left hand side, we have the real part is 2x minus y, and the imagined part equals x minus 2y. So we can say that 2x minus y equal 5, and the x minus 2y equals 1. The coefficient of I here is 1. The imagined part equals 1. And we write it. So 2x minus y equal 5. It is equation 1. and x minus 2y equals 1. It is equation 2. And from 2 we can find that x equals 1 plus 2y. X equals 1 plus 2y, and we have new equation is 3. Then by substituting from 3 in 1, don't substitute again in 2. So we have 2x minus y equal 5. Then substituting x equals 1 plus 2y, what we get? 2 multiply 1 plus 2y minus y equals 5. And we simplify the left hand side. 2 multiply 1 equal 2. 2 multiply 2y equals 4 minus y equals 5. 4 minus y equals 3y, and 5 minus 2 equals 3. So we have 3y equals 3. Again, 5 minus 2, you can put here 5 minus 2, it's equal 3. And 4y minus y equals 3y. Dividing both sides by 3, the coefficient of y, we can get that y equals 1. Substituting y equals 1 in equation 3. So to get the value of x, so we have x equal 1 plus 2 multiply 1. So the result equals 3. I mean x equal 3. From equation 3, we have x equals 1 multiply 2 by 1. Substituting y equals 1, because we calculate it equal 1. So x equal 1 multiply 2, which equal 3. Find the values of x and y which satisfies the following equation. 2x plus 1 plus 4yi equals 5 minus 12i. So 2x plus 1 equal 5, and 4y equals negative 12. The real part equals the real part, and the imagined part equals the imagined part. So 2x plus 1 equal 5. 2x equals 5 minus 1. 2x equal 4. Then x equals 4 over 2, which equal 2. And this is the value of x. And we have 4y equals negative 12. Negative 12. Don't forget the negative sign. So 4y equals negative 12. Then y equals negative 12 over 4, which equal negative 3. Operation on complex numbers. Find in the simplest form the result of each of the following. 7 minus 4i plus 2 plus i. B. 2 plus 3i multiply 3 minus 4i. We have here the addition operation and the multiplication operation. Solution. The expression 7 minus 4i plus 2 plus I equals 7 plus 2. We collect the real parts, 7 plus 2, and we collect the imagined part. It will be negative 4 plus 1. The coefficient of I here is 1. And 7 plus 2 equals 9. And the negative 4 plus 1 equals negative 3 I. So the sum of these two complex numbers is a complex number. 9 minus 3i. Here we have the multiplication. The expression 2 plus 3i multiply 3 minus 4i equals. We multiply 2 by 3 minus 4i. So we take the first term, multiply by the brackets. plus 3i multiply 3 minus 4i. And we expand the brackets. So 2 multiply 3 equals 6. 2 multiply negative 4i equals negative 8i. 3i multiply 3 equals 9i. 3 multiply negative 4i. Again, 3 multiply negative 4 is 12. I multiply I is I square. And the positive by negative equals negative. Again, 2 multiply 3 equals 6. 2 multiply negative 4i equals negative 8i. And we will multiply 3i by 3 minus 4i. So we have 3i multiply 3 is negative, 3i multiply 3 is positive 9i. And 3i multiply negative 4i is negative 12i power 2. And don't forget that I power 2 equals negative 1. So we can write 6 minus 8i plus 9i plus 12. Why? Because I square is negative 1. Negative 1 multiply negative, it will be positive. Now we collect the real parts and the imaginary parts. So 6 plus 12 equals 18. And the negative 8 plus 9, we put it in one bracket. It is the coefficient of I. Negative 8 plus 9 equals 1. So the product equals 18 plus I. Conjugate numbers. Conjugate numbers. The two numbers a plus bi and a minus bi are called conjugate numbers. Here we have the same numbers a and b, but we have different signs to the imaginary parts. Here is positive and here is negative. And we have some properties for this. For example, 4 minus 3i and 4 plus 3i are two conjugate numbers, where the product of them, 4 minus 3i multiply 4 plus 3i, we can find here a difference of two squares. 4 square minus 3i squares. Again, we have 4 minus 3i multiply 4 plus 3i, the product of two conjugate numbers. It is the square of the first, square of 4 minus square of the second. Square of the second term, square of 3i, it will be 3i square. And we have 4 square is 16, negative, negative. 3 square is 9 and the I square is I square. Again, don't forget that I square equals negative 1. So we can write 16 minus 9i square equals 16 minus 9 multiply negative 1. And the result will be real number is 25. So the result is a real number. And directly you can say 4 minus 3i multiply 4 plus 3i equals 4 square plus 9 square. 4 square plus 3 square. It will be 16 plus 9, which equal 25. And the result of summation is, we have 4 plus 4 equals 8. Negative 3i plus 3i equals 0. So the sum is a real number. So the product of two conjugate numbers is a real number. And the sum of two conjugate numbers is also a real number. How we use it in problems? We have this example. 18. Find the values of x and y which satisfy the equation 2 plus I multiply 2 minus I over 3 plus 4I equals X plus IY. First, 2 plus I multiply 2 minus I equals, the square of first will be 4 minus the square of the second minus the square of I minus I square over 3 plus 4I. So the first step we can write 4 minus I square, square of first minus square of second, and negative I square is positive 1 as I square equals negative 1. So negative 1 multiply negative will be positive 1 over 3 plus 4y. All of this equals X plus IY, X plus IY. And simplify, 4 plus 1 equals 5 over 3 plus 4I equals X plus IY. We want to get rid of this denominator, of this complex number in the denominator. So we multiplying up and down by the conjugate of this number. What is the conjugate of 3 plus 4y? It's 3 minus 4i over 3 minus 4i. Again, to make the denominator is a real number, so we'll multiply the whole fraction up and down by 3 minus 4i over 3 minus 4i. It is the conjugate of this denominator. Don't forget that. 3 minus 4i over 3 minus 4i equals 1. So we will not change the value of this fraction by multiplying by 1. We only change its form. So we have numerator by numerator, 3 multiply 3 minus 4i over the product of these two numbers, the product of these two conjugate numbers. It is the square of the first minus square of the second. So the square of 3 minus square of 4i equals X plus IY. And 5 multiply 3 minus 4i, we write it. What is the value of 3 square? It is 9. What is the value of 4i square? It is negative 16. Negative 16 multiply negative, it will be positive 16. As the value of I square is negative 1, so we must change this sign. 9 plus 16 equals 25. And now we simplify this form. Notice that we got a real number in the denominator by multiplying up and down by the conjugate. So 5 multiplied 3 is 15 over 25 equals 3 over 5 minus, we have it here, 5 multiplied 4i equals over 25 equals 4 over 5i. 5 multiplied 4 is 20. 20 over or divide 25 is 4 over 5i. So x equals the 3 over 5 and y equals the negative 4 over 5, and this is the solution. Question: find in the simplest form the value of the following: 4 minus 6i over 2i. Now you can take a break and solve it by yourself and review the solution. We have 4 minus 6i over 2i. 4 minus 6i over 2i. We wanted to make the denominator is a real number, so multiplying up and down by the conjugate of the denominator. The denominator is 2i. The denominator is 2i. Then we're multiplying up and down by negative 2i. Negative 2i over negative 2i. And we put it in another fraction. It is equal, here equal, 4 minus 6i, 4 minus 6i multiply negative 2i. 2i multiply negative 2i. We put it here. And we distribute negative 2i over 4 minus 6i. How? Negative 2i multiply 4 equals negative 8i. Negative 2i multiply negative 6i equals positive 12i power 2. As negative by negative is positive, and 6 by 2 is 12. I multiply I, it is I square, and don't forget that I square equals negative 1. And 2 multiply negative 2 is negative 4. I multiply I is I power 2. Then we simplify. Negative I is negative I. 12i square equals negative 12. Negative 4i square is positive 4. And we divide. Negative 8i over 4 is negative 2i. Negative 12 over 4 equals negative 3. And we arrangement, it will be negative 3 minus 2i. And always you can make sure that you have the right solution by using calculator. You can write this. You can turn the mode of calculator to complex number and write 4 minus 6i over 2i. Press equal, you will get this solution.